Welcome back. Nice to see you again. Glad to know that you came back to see me. This is Math 168, and I'm Professor Needing. We're going to go to section 1.2, sample from a population. So, as you know, what we're going to be working from are the PPTX handouts that were given to you in class. And I have quite a bit of annotating on this one I have to do, I think. So I'm going to actually move myself completely out of here, and you don't need to see me. You know who I am, and we're going to make me go away. There we go. So when we talk about sampling from a population, here are the things we're going to discuss. We're going to talk about a sample versus a population. We're going to talk about statistical inferences. We're going to start talking to wordings of sampling bias and what that means for us in the sample set, and simple random samples and other sources of bias. So bias will be a big hitter today. First of all, a population. So when we talk about a population, it includes all of the individuals or the objects of interest, meaning everybody, all, the whole group. And by the whole group, we're not just talking about the whole group of people sitting in my classroom. It's the entire campus of LCC, the entire state of Ohio, the entire United States, the entire world. A population is a very, very large group. And when we sample data, we don't sample everybody in a population because it's impossible, and we'll talk about that further. A sample are the cases that we have collected data about. You can think about this like a subset of the population. And I think that's a nice thing to say, is that a subset of a population is a smaller set that came from the actual largest set that was available. Okay, so think in terms of that subset. A statistical inference is the process of using data from a sample to gain information. That's a big deal right there. Gain information about, again, the population. All of this is about looking at the population. And in this next slide, we're going to see that actually take place. And I'm going to scoot that back just a little so we can see it better. So the big picture here. The big picture is we go to all LCC students and we make them our population. So it's everybody that exists who is an LCC student. From there, we take a sample. We take 100 students, 200 students, whatever we take, but we take a sample. So we don't take all of them, but we take a sample. And from that sample, these samples are the students, and they are in this class. So like all of you, my students, you are the sample. Then I do some kind of statistical analysis on you, and then I make a statistical inference back about the population. In other words, I'm going to make an inference about the larger group of LCC as a whole based primarily on what I see from the data from you. That's really what we're going to make a statement about. So you can see that could introduce a whole area of inaccuracy if we didn't properly gauge students, if we didn't properly ask questions, if we didn't properly do our job, that we could be making statements about a larger population that just simply aren't true. Here's a couple of questions that might come to you in Wiley, and we'll make sure we hit these along the way. 1. State whether the data are best described as a population or a sample. And it says, to estimate the size of trout in a lake, a person records the weight of 10 trout. So I'm going to kind of underline that or highlight that, 10 trout. Right there. He catches over the weekend. Okay, well, these are 10 things out of the lake. So when we're talking about a population or a sample, this clearly has to be a sample. Subscription-based music website tracks its total number of active users. So it's telling me, first of all, that I have gained access to all of them, total. And we're talking about active users, so people who are actually in there. And I did a comment there. I didn't want to do a comment. I wanted to do a highlight markup, sorry. Total number of active users. So therefore, we'll say that this is a population of their active users. Oops. Ignore that little capital O. typing skills. Wow. A questionnaire to understand athletic participation to a college campus is emailed to 50 college students, and all of them respond. Okay, now this one can get a little tricky for students. First of all, notice it's got this word, all of them respond. So a lot of students like to jump on that this is a population, but it's not a population. Remember, it's on a college campus, and we emailed it to 50 people. And because we sent it to 50 people, that is a sample, okay? Just because all of them responded, that's just a fact about the 50 that are on the college campus. So these are going to be a sampling. And I think I can make a comment about this right here. It says I can convert to a comment. Now I don't want to do that. You can do a lot of stuff with this new thing, and it drives me crazy, all the things that I can actually do. So it's going to be a sample. There you go. And again, look at this. For some reason, I love to type my second letter I'm going to just make everything lowercase from now on. Let's talk sampling bias. So in sampling bias, bias occurs when the method of sampling causes the sample to differ from the population. I somehow alter the true statistics that I should get. And people have a great ability to do this and not actually want to do it, but it actually happens very, very often. In sampling bias, we cannot trust the generalizations, and the generalizations are what apply to the larger population. It says people are terrible, it even capitalized all of terrible, at selecting a good sample. Even when we explicitly try to avoid the sampling, we are not good at it. We just can't avoid it. It's human nature. And we'll talk about those different ways it's human nature in a second. Selecting a sample that is similar to the population, only smaller. That's our goal. Our goal is to get a population representation, but have it in smaller numbers so we can actually analyze it. We can't analyze everybody in the United States, but what we can do is we can take a true sampling of people in the United States and we can make inferences about that. I mean, we do it all the time. We're about to do it for the presidential election. And we'll take a sampling and we'll do polls and we'll do things and we're already predicting who we think will or who we think won't. But we know that those aren't the dead-on number, and things can change. In random sampling, it says the biggest thing is, and it's in huge letters for you, is to take a random sample. So for instance, this is a really good idea. You take all the names of everybody in a unit, maybe class or the campus, whatever. You put them all in a hat and you draw out names at random. That is a super random, non-biased way of doing things. So when you make that kind of draw on a sample, you're giving everybody equal access to the being part of the sample and getting in on that. It says more often we use technology. We're going to use graphing calculators and Stack here. How we'll use technology to help us, because we're not going to be able to put a bag together or a hat together and have everybody draw their name out of it. So here's a random sampling. Before the 2008 election, the Gallup poll took a random sample of 2,847 Americans. 52% of the sample supported Obama, and in the actual election, 53% voted for Obama. So the numbers were super close based on that it was a really good sampling that they took during the 2008. Had it been a biased sample, then it would not have been nearly as close in that statistical value. And to be within 1% is really, really good. To be random versus non-random, a random sample have averages that are centered around the correct number. That's big for you right there. Centered around the correct number. Only random samples can truly be trusted when making, again, here we go, generalizations about the population. So first of all, we have to make sure something is random. Random has to be on the forethought of your brain initially. Example, in a random sample of 3,500 Canadian customers, about 71% reported they regularly stream music. Is this sample likely to be representative of all Canadians? Is it reasonable to generalize this result and estimate that about 71% of Canadians regularly stream this type of music? So when we talk about a sampling of something, when we look at something, to say that 3,500% it's a random sample, and because it's a random sample, and as long as we've done a job well, given the information we know here, and it says 71% regularly do this, well, if it's random, then the sampling is likely to represent customers. But it goes on to say, isn't it reasonable to generalize this result and estimate that about 71% of Canadian customers regularly streaming music? It depends on the sampling that was taken. Did the sample represent all Canadians? Was the random sample just simply random in a particular area? What was the age group of the random sample? So we have to delve deeper into when we have this discussion. Bowl of analogy soup. So here's an analogy for this. So first of all, let's say that the population is the entire bowl of soup, and let's say a sample is whatever part you're tasting out of the soup. And it tells you that if you just dive right in and you blindly take a big old scoop out of there and you eat it, and you either like it or you don't like it, you've taken a nice random sample because you've got all the little bits and pieces that are inside the soup. But if you're like my kids and you go in and you spoon out what you like out of the soup, you're really not getting a good sampling. You're getting a biased sample because you're taking out the things you like and you're eating those. Because if you steer away from the vegetable or you steer away from the whatever you don't like, then you're not really sampling the entire thing. So think about when you take a sample, that sample has to be blindly taken to where everything has an equal chance of getting into the unit. At the bottom it says, in a simple random sample, each unit of the population has the same chance of being selected. So here's some realities of sampling. And I kind of lost where I was, and I had to get to it. There we go. While a random sample is ideal, often is not feasible. We can't get to the entire population. Maybe not available, maybe impossible, maybe too difficult to contact everybody. Sometimes your population of interest has to be altered to make it more feasible. Generalizations are results of limitations of population that was actually sampled from. Depends on, it just happens that sometimes I have to alter this for some reason. Maybe I have some severe outlier data that was extreme, which is affecting the entire group. In practice, think hard about the potential source of the sampling bias and try your best to avoid it. You're not going to be doing any sampling, but you have to be able to analyze sampling. Here's some methods of sampling we can talk about. State whether the sample is biased or not biased, or random or not random kind of thing, right? Okay, so we're looking for a random sample from the given population. It says the population is approximately 2,400 protein coding genes in human DNA. Each gene is assigned a number from 1 to 24,000, and a computer software is used to randomly select 300 of these numbers, yielding a sample of 300 genes. This is incredibly random. The computer goes in, the computer has no care in the world. The computer just simply assigns something, and then think about it like it's dropping it into a big old hat, and it just simply grabs them out, random. The population is all people who visit the website CNN.com. All visitors to the website are invited to take part in a daily online poll. Okay, well, this one is going to be a not random value because, first of all, it's not random because we're just looking at the people who visit CNN. And of this, people are invited, so it's volunteer basis. And a volunteer basis is never good. Because the only people who respond to volunteer basis are either those very strong or very negative against whatever the topic happens to be. So this is a non-random sample. It's non-random because, first of all, you were in a site only. Now, if you went in and you took all the people who visited and you shook them all up in a hat and you pulled them out, then that would be random. But you allowed them to pick their own status within the group. The population is adults between ages 18 and 22. A sample of 500 students is collected from LCC and each student at LCC had an equal chance of being selected for the sample. Okay, well, first of all, look at the population. The population is adults between 18 and 22. All right. And then we take a sample of 500 students is collected from LCC, and each student at LC has an equal chance. So our LC students are a representation of adults between 18 and 22. LCC is an open community college. Community college has far more reaching ages than 18 to 22. We have ages all over the gamma, and that would not be a good representation of the population. However, though, as far as being random, it says a sample of 500 students is collected, so it would be a random sample, and each one has an equal chance. So we would say it is random, but I would also make a notation that it's not going to be a good representation of the population. But we weren't asked that question. We were asked, is it random or not random? And yes, it would be random. Here's some sampling methods. And now let's talk bias and not bias. So state whether this is a bias or a non-bias situation. Suppose you want to estimate the average number of hours that students spend studying each week. So I'm looking for studying hours. You go to the library and you ask all the students there how much they study. Well, think about what you've done. You've just gone to an environment which people normally go to study, and you're asking you, are you studying? This is a bias solution. If you want to talk to people about their study habits and find out how much people really study, you need to find a population to draw your sample from that doesn't just include those who are studying. You email all students and you ask them how much they study, and you use all the data that you get. Well, you email them, you allowed them to answer yes or no, you gave them that choice, and therefore you have a bias situation. Allowing somebody to respond, again, is the same as introducing that critical left or that critical right person. Generally speaking, those who don't have much to say about the topic are not going to answer at all. They're just going to continue to walk by or not answer, and you're not going to get a good sampling. So we have another bias because of volunteer participation. I'm going to write that volunteer. That should be a dead giveaway when you see the word volunteer going on. Take 10 apples off the top of a truckload of apples and measure the amount of bruising on those apples to estimate how much bruising there is on average in the whole truck. Well, you focused on the on top part of this, and because it was an on top part, you didn't get the bottom of the truckload of apples. So therefore, you biased the situation, and again, we would have a bias because of a bad sample. Again, it's incredibly hard to get a non-biased situation happening. Not one of these is computer generated. Not one of these is done by technology. And generally speaking, when we do this as people, we are not very good at it. Bad methods of sampling. Sampling units based on something obviously related to the variable you are studying. For instance, sampling only students in the library when you're asking how much they study. That's the one we just talked about, bias. Go to fitnessmagazine.com. Ask the question, have you hired a personal trainer? Well, first of all, you're on a fitnessmagazine.com. People who go there probably more than likely are into fitness, and you're asking them about a personal trainer, or they want to be into fitness and you're asking them. You're not going to get a very good sample at all. So you have bias in both situations given here. These are bad methods of sampling. Continue. Letting your sample be comprised of whoever chooses to participate. This is the one I've hit on 2 or 3 times. Do not allow people to have a choice, yes or no. You're either in the study or you're not in the study. You were chosen to be in the study or you weren't chosen to be in the study. People who choose to participate or respond are probably not representative of the entire population. Like I said, they're extremely left and extremely right, and you're not getting that balance in the middle of what you're really looking for. You're looking for a true sample of everything, left, center, right. This would come from emailing or mailing an entire population and then making conclusions based on those who choose to respond. And again, your Your key terminology there are you chose to respond. An airline emails all of its customers asking them to rate their satisfaction with their recent travel. Again, you send an email. An email is, I hit delete more times than I hit I'll keep something when I'm talking about email. My boss is probably listening to that right there because I think his emails are the ones I delete first. Other forms of bias. Even with a random sample, data can still be biased, especially when collected on humans, okay, or by humans. Other forms of bias to watch out for in the data collection. Question wording. I can change question wording pretty easily and change how we get answers. Context, the inaccuracy of responses, and many other possibilities. Let's look at some question wording. So here's a question. So a random sample was asked, and here's how the question was asked, and this is actual data. Should there be a tax cut, or should money be used to fund new government programs? Well, right away, people who were given this question in a survey, said 60% of them said, I want a tax cut. And 40% of them said, I want programs funded. So clearly, the majority wants tax cutting. They took the same question and they reworded it. Should there be a tax cut, or should money be spent on programs for education, environment, healthcare, crime fighting, military defense? So we're being a little bit more leaning on the person's side of right and wrong within their society. And look at the difference in the numbers and how they changed. And it went back to the same population. So the data comes from the same population. Tax cuts went from 60% down to 22%, and program funding went from 40% to 78%. Lots of money is spent in this country, in this world, in our environment on getting questions written in a proper format so you can get the responses you want. Okay? And I'll leave it there because that's a whole another course on how to approach that PR situation. So back in 1976, and most of you are probably way too young to even have any clue about 1976, there was this artist, or this popular columnist. She wrote in the newspaper. Her name was Ann Landers. If you could look her up, you could check it out if you have nothing better to do in your life right now. And she would write, and she would write to people. People would write into her and ask advice, and she would write back. And so Ann Landers put in her column asking for advice on whether or not to have children. Ann ran a letter from a young couple, which included various reasons not to have kids, but no positive aspects of parenting, asked her readers to respond with this question. So she wrote an article, and then she said, hey, please write in and tell me what you think. If you had to do it over again, would you have children? Okay. And over 10,000 responses. There were people answered yes and people answered no. Okay, well, I have the data written down and I have to give it to you. So when people wrote back in to this, they wrote down, and I got to get my typing. Give me 1 second. 30% of the readers responded that yes, I would do it again. Okay. Ann Landers, and back in 1976, was absolutely flabbergasted that 30% of the people, of the 10,000 who responded, said yes, they would have children again. She was absolutely belligerent about the situation. So she went back on again to write another article the following week or 2 weeks later, whatever long it took. And the article she wrote was pretty much a scathing, telling people how our society relies upon young people. It's your obligation to take care of children. It's your obligation to raise them properly. Our world will not be where our world is not if we don't take care of the children's society. And she reran it, and she said, people, please rethink your decisions and write back in. When they wrote back in again, and this is just the power of people and how they can change our world. 95% of the more than 10,000 people responding decided that, I made a mistake and I should have responded yes. So you can see how just simply putting bias into wording, pressure, those kinds of things, incredibly alters the situation or the data that we get. So that's what we have to eliminate from the situation. We can't be the Ann Landers and tell people that you made a boo-boo, you need to fix that now. It says data is collected on a random sample, and we use this data to infer about a larger population. Sampling biases occur when the sample does not resemble the population. Remember, we want a mirror image, but smaller. Sampling bias can be avoided by random sampling, and bias exists in the sample data do not accurately reflect the true population. A bias can occur in many, 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 many ways. In chapter 1.3, when we come back, we'll talk about the experimental parts of an observational study. I'll see you then.